Hi, welcome to this video. Now in this video, we're going to do some problem solving on grade 11 questions, electrostatics for exam preparation. Without wasting any time, I would like us to go through the questions. So now let us start with question number 8. Question number 8, it reads as follows. It says, two charged spheres, which is sphere X and sphere Y, are placed in a vacuum at a distance of 0.04 meters apart. And we can see that sphere X and sphere Y, they have their own magnitudes. Sphere X, it is charged to be positive, and sphere Y, it is charged to be negative. So 8.1, it says to us, draw the resulting electric field pattern between the two charges. So when we draw the resulting electric field pattern, we're going to use what we call electric fluxes. The electric fluxes are the field lines that flows. It's either through the charge or out of the charge. So these field lines, for them to flow through the charge, it's because the charge, it is negatively charged. But now, when the flux lines, they flow out of the charge, it's because the charge, it is positively charged, okay? So here we have two charges, which is X and Y. So we want to draw the resulting electric field pattern between the two charges. So to answer question number 8.1, we're gonna take field electric charge X, which is, remember, positively charged. Just gonna write it as positive, which is charge X. And I'm also going to take charge Y, which is negatively charged. And then this will be a charge Y. So magnetic field lines, they move from positive. Please mute your mic. Mute your mics. Mic, please control your mics. So now, the field lines, they move from positive to negative all the times. So we can see that we have the interaction between these two charges. Each and every time when you're asked to draw the field lines, make sure that you use a straight line between the two consecutive charges, okay? And therefore we know that we're gonna have the field lines that moves in this way, the field lines that moves in this way. And then here, you can have something that looks like this, and then here we have something that looks like that, here and here. Then here we're gonna have straight line. So here we're gonna have straight line. And then let's say here we're gonna have something that looks like this. Make sure that these lines, they act perpendicular to the surface of the sphere. But these lines that are found close to these two charges, like these field lines, they're not supposed to be perpendicular to the surface of the sphere. They're supposed to point as if they're directed towards that sphere. So same applies over here. We're gonna have something that is perpendicular to the sphere. And then even these ones, we're just gonna tilt them a little bit, tilt this one a little bit, tilt this one a little bit, and tilt one a little bit. So remember, the flux, they move from positive to negative, from positive to negative, to negative, to negative, to negative. And then here, we write the arrows that points towards the center of the negatively charged sphere. And then for the positively charged sphere, our field lines, they're gonna move out of the sphere, okay? They're gonna move out of the sphere, as we see over here. And therefore, this is how we draw the resulting electric field pattern between two charges. This is between the two charges. If they wanted only one charge, that means maybe X, which is positively charged, we're going to consider this field pattern. But you have to take note that if you draw one field pattern, but there is a question like that, we'll do it. All of these field lines is supposed to act perpendicular to the surface. It's very important how you draw these things. You do not just draw them because you have to. You follow or obey the rules. I hope that was clear. Therefore, that means we move to question number 8.2. 8.2, it says to us, calculate the electrostatic force sphere X experiences due to the charge on sphere Y. So we want electrostatic force of X. We want electrostatic force of X due to sphere Y. Okay, to sphere Y. So remember, when you want to calculate the electrostatic force, we use Coulomb's law, which is almost the same as the universal gravitation. But instead of G, we use K, which is going to say Q of, remember, you're talking between X and Y. I'll just say Q of X multiply by Q of Y, divide by square distance between them. So now remember, K, it is always denoted is electrostatic constant, which is given to be 9 times 10 to the power of positive 9. Therefore, what is the magnitude of Qx? The magnitude of Qx, remember, it's given in micro, not nano. Remember, when it's nano, it's going to be a symbol that looks like this. Nano means to the power of negative 9. Micro means to the power of negative 6. Okay, pico, which is p, to the power of negative 12. And then this is macro. We have micro, which is it's going to be m. Coulomb is going to be to the power of negative 3. You should be able to distinguish all of these Greek symbols if they are used. So Qx is going to be to the power of negative 6. It's going to be 5 times 10 to the power of negative 6. And therefore Qy, it is the same magnitude. But remember, we do not substitute the negative number over there because we will denote the direction at the end of the calculation. So here we're going to have 5 times 10, again to the power of negative 6, divide by distance between them. It's already given in meters. It's very important to make sure that your units are in meters for the distance. So it's 0.04, 0.04 to the power of 2. And therefore we punch this on our calculator. We have 9 times 10 to the power positive 9 multiply by 5 times 10 to the power negative 6 multiply by 5 times 10 to the power negative 6 once more again, divide by 0.04 to the power of 2. And then we get that our final answer will be 140 decimal places 6.3 newtons. It's a newtons, it's a force, okay? But this type of force is called electrostatic force. So now, again, it's very important to write your direction. But now, how are you going to write the direction? Are you going to write to the left? Are you going to write to the right? So now, here's the thing. If they said to you, calculate electrostatic force between X and Y, your direction over here, you're supposed to say it is attraction. Remember, calculate electrostatic force between X and Y. It's either attraction or repulsion. Because these are opposite charges, definitely the direction will be attraction. But this question, it says to us, calculate the electrostatic force sphere X experiences. So meaning we are focusing on sphere X. So that means sphere X experiences due to the charge on sphere Y. We want to know that when sphere X sees sphere Y, where will sphere X move? Sphere X, because this is attraction, most definitely will move towards Y. But which direction will sphere X move? That means sphere X will move to the right, okay, towards Y, because this is where Y is placed. Y is placed on the right-hand side, and these two spheres are both, one is positively and one is negatively charged. So it's an attraction, but sphere X will move towards Y, which is to the right in this case. So the direction that we're going to specify here, we're going to say to the right, okay, because they said it's very important on how to read the question so that you answer it correctly. Okay, that's how it works. That will be 8.3. 2. Now, we move to 8.3, which is 8.3.1. But let us read 8.3 first. So it's already 8.3.1. Now they say to us, if sphere y, which is this sphere, if sphere y is at a fixed position, meaning sphere y is not moving at all, and the sphere x is free to move, will the acceleration experienced by sphere x towards sphere y be constant? Write down yes or no. Most definitely, for you to write down yes or no, you need a reason why, so that you understand why did you write yes or why did you write no. Now, the follow-up question, which is 8.3.2, it says, explain the answer to question 8.3.1 by referring to the electric field and the force. This is very nice. Now, before we can even try to solve this question, let us try to draw the very same scenario that they are talking about. So they say sphere y is gonna be placed constant, means it's gonna be placed fixed. It's gonna be fixed at this position. But the sphere that will be moving, it's sphere x. We can see that obvious, the electrostatic force between these two, because this one is positively charged and this one is negatively charged. Obvious, sphere x will move towards y. So the question is, what will happen with the acceleration experienced by sphere x as sphere x moves towards y? We want to know what's going to happen with the acceleration. Now, the acceleration experienced by sphere x towards sphere x will be constant. We're going to get yes or no. So the answer to 8.3.1, the answer is no. The acceleration of sphere x towards y, it won't be constant. Why is that the case? It's because we need to understand that sphere y, it has what we call the field lines. Sphere x, it has what we call the field lines, like 8.3.1, how we draw it over there. What you have to understand is that the field lines, they become stronger towards the charge. So from this position, as the sphere x moves towards y, you have to understand that the field lines of sphere y at this point, they are weak. The field lines of sphere y around this point, they become to be stronger. But the field lines of sphere y next to sphere y, when x gets here, now x will experience stronger field lines of sphere y. So that means the acceleration of x will increase as x moves towards sphere y, because the more x moves towards sphere y, the greater x experiences higher electric field strength. Okay, so that means in this case, the acceleration experienced by x, it is not going to be constant. So the answer is no, it won't be constant. Now, what will be the reason for 8.3.2? Explain the answer to question 8.3.1 by referring to the electric field. Like I said, electric field at the center, towards sphere y, it is stronger. But electric field away from field y, it is weaker. You understand? So that means we're going to say the electric field is stronger closer to the charge. It's stronger, closer to the charge. Therefore, the acceleration will increase due to continuous motion of sphere X to sphere Y. To sphere Y, okay? This is how it actually works, okay? To get your full marks or your 2 marks, this is how you're going to explain it. The most important thing that we need is stronger, closer to the charge. That's the first point. And the second point that we're gonna mark in exam is you spoke about the acceleration will increase towards sphere Y. Okay, it won't be constant. That's why we said no. That means what's going to happen if the acceleration as X moves towards Y? The acceleration will increase with a continuation as X moves towards Y. I hope that was clear. Now we move to the last question of the question, which is 8.4. Now 8.4, it says to us, a third sphere, which is called sphere Z or Z, with a charge of -4 microcoulomb, is placed at right angles to sphere X and at a distance of 0.03 meters from sphere X, like we see here on this diagram. Calculate the magnitude of the net force. We want the net force, but net force on which sphere out of the three? On sphere X, on this sphere. On sphere X, due to the other spheres, due to sphere Y and sphere Z. So that means we want to know that we're gonna determine the magnitude, we're gonna determine the electrostatic force. It's up to you. You can start between X and Z, or you can start with between X and Y. So let's talk about X and Y. We have already determined this one. Question number, I think it was 8.2, yes, between X and Y. So the electrostatic force between X and Y, I'm just gonna write it over here. So the electrostatic force between X and Y, we determined it on question number 8.2, which was 140.63 newtons. 140.63 newtons. And let me tell you this, if this was linear, if these charges were placed on a straight line form, the direction is very, very, very important, whether it's left or right, because when you determine F net, you're going to have to add or subtract. But because they are placed in right-angled triangles, our direction will be determined by the use of trigonometric ratios. Normally we use tan. You can use one of the two if you know your hypotenuse. So in this case, we don't even need we just need the magnitude. Okay, it's 4 marks, we just need the magnitude. So the force, it's fine, you can write the direction, but it's not that important for this question at this point in time. Now, electrostatic force between X and Y, it is this one. Now, let us determine the electrostatic force between X and Z. So electrostatic force between X and Z is going to be how much? We're going to use Coulomb's law equation, which is denoted by K, multiply by Q of X, multiply by Q of Z, divide by R squared. It's fine. You can say Q1, Q2, it is still okay. Now, our electrostatic constant is given to be 9 times 10 to the power of +9. And then the magnitude of Qx is given to be 5 times 10 to the power macro, 10 to the power of -6 coulombs, multiplied by Qz. It's going to be 4. 4, remember, we do not substitute our negative number over there. So it's going to be 4 times 10 to the power of -6 coulombs, divide by distance between them. It's in meters. We are safe to substitute it as it is, which is 0.03. Do not forget your squared over there. I've realized when I marked the question papers, learners normally used to forget the square there when I was marking. So now let us try to punch this on our calculator. So we open up the fraction. So we go 9 times 10 to the power positive 9, multiply by 5 times 10 to the power negative 6, multiply by 4 times 10 to the power negative 6, and then we go 0.03 to the power of 2. Do not forget to the power of 2, that's squared. So we get that our magnitude of force optic op is 200 newtons. So this is Fxz. So this is a force between x and z. We might manage to determine the force between this and that one. So it's fine. You can use the directions. We can see that x will move upwards because force of attraction between positive and negative. Okay, so x will move upwards, and then here x will move. It's again force of attraction will move towards y, meaning will move to the right. X will move to the right. You can use your tail to head method. This is also physics, and therefore this will be F net. Okay, this will be F net of here. Remember we said it's here to here. It is F x y, and then here on this side it's F x z. Here we have F x z. Okay, the perpendicular over there, we can determine our hypotenuse. In this case, the distance is going to be here, but it's not that important because they didn't say determine, or it's even 4 marks, so you don't want to waste time for nothing. So to determine F net, you're going to say F net is equals to, you use your Pythagoras theorem, right? F net is your hypotenuse, it's opposite to 90 degrees. So you're going to say fxy to the power of 2 plus fxz to the power of 2. Now, what is fxy? We said, here's it, fxy, it's 140.63 to the power of 2 plus xz, we just determined it over here, it's 200 newtons to the power of 2. So remember, on this side, you have F net squared, not just F net. So it's mathematics. Be careful. We say 140.63 to the power of 63. I'm writing 62 now. Plus 200 to the power of 2. And then I get 5 something, and then I'm gonna root my answer. Already I'm gonna root my answer. I can even root it from here to show that I have already inserted this. I don't want to do a lot of steps that are necessary. So it's gonna be 2, 4, 4, my final answer, comma, 2 decimal places, 4, 9 newtons. Therefore, this would be net force experienced by X due to these other 2 charges. Okay. Right. Question number. So now let's move to question number 2. Question number 2, it reads as follows. They say to us, draw the electric field pattern associated with a negative point charge. So this question is the same as the question that we started with in the previous question, but here now we are talking about one charge, which is point charge in this case, which is negatively charged. Okay, so to answer question number 2.1, they say to us, draw the electric field pattern associated with a negative point charge. So this, let me write it over here. This is my charge, which is negatively charged. Remember, the flux lines, when you draw them, make sure that, guys, go with something, maybe, I don't know, something circular, man, so that when you draw this circle, it is a perfect circle, okay? So when you draw your point charges, make sure that your lines, they act perpendicular to the surface. They're supposed to act perpendicular to the surface of the circle. So with your ruler, straight line, draw this line and draw this line simultaneously, okay? Again, place your straight line, your ruler like this. You're gonna draw this line. You're also gonna draw this line. Place your ruler in this way. You're gonna draw this line. You're gonna draw this line. Place your ruler again. you're gonna draw this line and make sure that it tries to be perpendicular, okay? It's very important because that's what they also mark. They don't just mark things that looks like this. Imagine you drawing something like this. So imagine you drawing something like this. No, 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 no. We don't want something that looks like this. This is like it's even like a sun. So we don't want something like this. We're gonna make you wrong, okay? We're gonna make you wrong. So make sure that you draw proper things there. Don't want some things that looks like crocodile there. Okay. So yeah. So this is how we draw it. Now the next thing that follows is the arrows. Okay. And make sure that these field lines, they do not intersect or they do not cross over each other. It's supposed to look like this. Now, because you're talking about a negative charge, remember it's towards the center, negative towards. Okay. So these field lines, they're gonna move towards the center of the negative charge, towards the center of the negative charge, towards the center of the negative charge, towards the center of the negative charge. And therefore, this is how we draw it. Obviously, I'm using this. You're gonna draw it nicely on your book, okay? All right. Now we move to 2.2. 2.2, it reads as follows. It says 3-point charges, which is A, B, and C of magnitude -2 microcoulomb, +4 microcoulomb, and -2 microcoulomb, respectively, are placed in the diagram as shown. The next, you see, one thing that I do not like, immediately when I see my unit in centimeters, I convert them, okay? So remember, from centimeter to meters, right? We're going to convert from centimeter to meters. King Henry died a miserable death called malaria. So that means in this case, we want to move from centimeters to 2 meters. We're going to divide by 100, okay? So that means that's the first thing that I don't like. I don't like this is negative. I get rid of it immediately before I can even perform my calculations. So going here, what is we're gonna say 10 divided by 100 is gonna be 0.1, right? So here we have 0.1 meters. And then here we're also gonna have 0.1 meters. That's the first thing that I start with. Okay. And then here I know it's -6, -6, -6, 10 times 10 to the power -6. Now, 2.2.1, it says to us, state in words Coulomb's law of electrostatic force. Okay. So here we are talking about what when you talk about the Coulomb's law. We are talking about this formula. You actually explain that you are explaining this formula. F is equals to K multiplied by Q1 multiplied by Q2 divided by R squared. This is what we call the electrostatic force. This electrostatic force is going to be experienced due to these two charges, the product, because you can see that we are multiplying the product of these two charges. And therefore, we can see that from this fraction, these products are at the top, and the product of these two charges are at the top. So this product is going to be directly proportional to this F. But because R is below the fraction, it is inversely proportional to this one. But we can see that our R, it is in squared. So we're actually going to explain this formula when we state Coulomb's law of electrostatic force, okay? So how do we state it? You're going to say the electrostatic force, right? Experienced by what? Experienced by 2-point charges in the universe is directly proportional to the what? To the product, right? To the product of the charges, and inversely proportional to the what? To the square of the distance between them. Okay. I hope you get it. And by the way, I know you also have the definitions. I know you guys from your respective schools, they provide you with these definitions. It is still fine. You can use them to be safe. Okay, but simply this is how we explain Coulomb's law. We are actually explaining this formula. Okay, if you forget, always write down the formula and remember the product because you're multiplying, remember the direct proportion, remember the inverse proportion. You know that if you have something like this, 1 over t, f is equals to 1 over t, f is directly proportional to this one, inversely proportional to t. As long as it is at the bottom, inverse proportion, at the top, direct proportion. Okay. That's how it works. And therefore, we move to 2.2. Point 2. Now, 2.2, it says to us, calculate the magnitude of the Coulomb force that A exerts on B. A exerts on B. We want force that A, what will A do to B? Will cause B to move towards it, but with what force? We want that force, because force of attraction, we can see B will move towards A. So in order for us to calculate that force, we want to calculate the magnitude of the Coulomb force. A exerts on B is going to be equals to K is equals to Q of A multiplied by Q of B divide by R squared. Now, K in this case is going to be 9 times 10 to the power of positive 9. And then Q of A, it's given to be negative 2. Remember, we plug it as positive 2 times 10 to the power of negative 6. It's microcoulomb. And therefore, for QB, it's positive 4. It's 4 times 10 to the power of negative 6 coulomb. And then we divide by our R in this case. Remember, it's already converted, which is 0.1. Do not forget your squared again, squared over there. And therefore, let's see on our calculator. We have 9 times 10 to the power of 9 multiplied by 2 times 10 to the power of negative 6 multiplied by 4 times 10 to the power of negative 6. I divide by 0.1 to the power of 2. And then we get 7.2. 7.2 newtons. Okay, so for a fact that they say calculate the magnitude of the net, for a fact that they say calculate the magnitude of the coulombic force A exert on B, where will B go when it sees A? I agree, A exert the force, it pulls B. A is the one that exerting force to B, meaning it's gonna pull B to itself. So meaning we're gonna say to the left in this case. Okay, remember I said it's attraction if they just say calculate the force between the two charges. You're gonna say attraction. You don't have to say left, or you can't say left or right because it's between. So that will be question number 2.2.2. Therefore, we move to 2.2.3. Now, 2.2.3 says calculate the magnitude of the net. Now we want net coulombic force that charge B experiences as a result of the other two charges. So we want filled by this one. So look, from A to B, we have distance of 0.1 meters. From B to C, we have the very same distance, which is 0.1 meters. And then this charge is the same as this charge. So this force and this force, they are going to be the same, okay? We literally said force A on B, it was 7.2 newtons. That means force A on C will also be 7.2 newtons, okay? So, but we want the net coulombic force. Remember, this is a right angle triangle. We're not gonna add them linearly. So that means we're gonna have to use Pythagoras theorem, okay? Which is given by this formula. We're gonna say F net squared is equals to F of A B squared plus F of A C squared. Now, f on AB is 7, 2 to the power of 2 plus 7, 2 to the power of 2. I'm just going to say mathematically 2, 7, 2 to the power of 2. I'm adding them. These are the like terms. You can do it however. So here we have f net squared. So I'm going to take root sign on both sides of the equation. I'm going to say root of 2, open bracket 7, 2 to the power of 2. And therefore I get that my f net in this case for 3 marks, it's gonna be to 2 decimal places, 10,18 newtons. Therefore, voila, I get my 3 marks. The last question, which is 2.2.4, it says to us, calculate the strength of the net electric field at B. So electric field, we use this formula and we want E net, okay? So we're gonna use that formula that says E is equals to F over Q. So I'm going to use F net. You know I'm going using F net because I want electric field at B. I have F net at B. So I'm going to use F net at B and then Q of B. This is very simple. For 3 marks, my F net in this case is how much? It's 10,18 newtons. And then my Q in that case is how much? It's for B, it's 4, right? It's 4 times 10 to the power of -6. Therefore, on my calculator, I'm going to say 10,18 over 4 times 10 to the power of -6. And then we get 2. I'm running out of time. We get 2, 5, 4,